image formation by concave mirror. Okay. And out of the two mirrors, convex and concave, we will be studying more of concave mirrors while we are studying for image formation, and we would be studying more of convex lens for image formation. So remember, in mirror, it will be concave, and in lens, it will be convex. So we'll study more of concave mirror cases. Convex also will study, but convex will be very less. The more diversity we will be seeing only in case of concave mirrors. Okay. And in order to process this is the most tricky part. Children get confused, they memorize. So you should know the prerequisite for this is that you should know what are the rules for image formation. Rules for image formation. Did you get a time to revise the previous class? If not, this will become a little bit difficult. Have you revised? Yes or no? Okay. So the rule is a ray of light which is parallel to the principal axis will pass through the focus after reflection. A ray of light which is passing through the focus becomes parallel to the principal axis. A ray of light which passes through the center of curvature comes back in the same path, and a ray of light that makes an angle at the of incidence at the pole gets reflected back with the same angle of reflection. These are the four rules. Okay. The first thing we will see is when एकदम समझने की कोशिश कीजिए, पूरा चीज आसान है. When object is placed between focus and pole. When object is placed between focus and pole, right? In all these scenarios, when you do numericals, you will be asked to comment on three things: size, number two, position, and number three would be nature of image. You have to comment on the images: size, position. Size can be two types, beta. Size can be either a magnified, or it can be smaller. Position, well, we have to say based on what position we get. And nature can be of two types. Either we can get a real image or we can get a virtual image. Right? These are the four possibilities that you will get. Size can be either you'll get a magnified image or you can get a smaller image. We will see a special case of smaller also. When it is extremely smaller, we use a separate word which is known as diminished. Okay, my voice may be a little bit less today, children. I'm not doing well, so pardon me for that. Position will vary based on the position the image is formed, and nature would be always talking about real and virtual. Okay, every numerical that you will solve, you have to speak about these three things: size, position, nature. Okay, understood? So magnified means when the image is larger than the object. Smaller means obviously when the image is smaller than the object. And position means where the image will be formed. Nature, real or virtual. Children, how to understand real? When we will talk about real, the identifier for real would be actual intersection of rays.
At the focus.
No, not focus, not necessarily focus. Actual intersection of rays, wherever the image is formed. And what is it for virtual? For virtual, it will be extrapolation. Okay. Extrapolation. Let's take the first case. When object is placed between focus and pole. Now, few shortcuts you need to understand. Your concave mirror, this will help you in examination. Your concave mirror will always give you real and inverted image. Always real and inverted image, except this particular case. Means in this case, what we will get? We will get an erect image and we will get a virtual image. This is the only case. Other than this, everywhere you will get a real and an inverted, except this case. Okay. Before going to the diagram, let us see some common understanding. Let us say I have got a spoon. This is my spoon. Now take a new spoon. अगर आपके घर में कोई नया spoon है ना, आप उसको ले लीजिए आज. And then this particular side is your concave mirror. Do you agree? This is my concave mirror. Beta, if you take the spoon like this, see, look at me. If you take the spoon like this, and if you take it at a far off distance, you will always see an inverted image of yourself. which proves that it will be always inverted. But if you bring the spoon very close to your face, which is our case, because our object is between focus and pole, your face will come seedha. You'll get a erect face. Have you understood? This is, and the best part would be, take the spoon and slowly start moving it away. There will be a point when suddenly your face becomes inverted. Right? These are tricks to remember. Concave will always give me real and inverted, except one case, when object is placed between focus and pole. So shall we see this particular criteria, this particular case, when the object is kept between focus and pole, what happens? Okay, so let's first make our mirror. Okay, the first job would be to make our concave mirror. This is a part of my concave mirror. Okay. This is a part of my concave mirror, and I would first draw the principal axis. So this is my principal axis, and let me etch the mirror now. Okay, very good. Once I have etched it, I will make it a little straight. Okay, I've etched it. Now, what will I do? I have to mark out all my points. So what are the points? This is my pole. This is my focus. And this would be my center of curvature, right? They should be exactly equal. This is my center of curvature. So I call this as C, I call this as F, and I call this as P. Have you understood? C stands for center of curvature, F stands for focus, and P. Now, where is the object? Look what I've said. Object is placed between focus and pole, anywhere between focus and pole. So let's place our object anywhere between focus and pole. Let's say the object is placed here. Okay, so let me change the color. The object is placed here between focus and pole. Fine. Now let's draw the arrow diagram for this. So how will the arrow diagram be? A ray of light which is parallel to the principal axis. Let's take this arrow. First of all, understand one or two diagrams, then start drawing. Okay, a line which is parallel to the principal axis. This is my arrow. This will pass through the focus after reflection. So this is passing through the focus. Let me now give me my direction. This is my incident ray and this is my reflected ray. Understood? Rule number one. To form an image, we need minimum two arrows, two rays. You can have more than two also, but two is sufficient for you. Okay. And the next one that we say, that if you have a ray, the next ray I'm trying to show it with blue, a ray which passes through the center of curvature. Okay, let's take a ray from the center of curvature in this manner. This is, oh, sorry, 1 minute, children. Okay, this ray is passing from the center of curvature. A ray which passes from the center of curvature comes back in the same path. So it has gone in this path, it has come back in the same path. Clear? इतना तक clear हुआ? ठीक है? अब देखो ये दोनों rays after reflection कैसा हो गया? Diverge out हो गया है. They can never meet. Look at the two rays. They have diverged out. Do you see, Janvi? Ariman दिख रहा है? Both the rays have got diverged out. They'll never meet. So what do we do? As I told you, there is only one case of virtual, and this is that virtual case. So we extrapolate those rays. इसको extrapolate करते हैं ऐसे. ठीक है? ये ऐसे extrapolate हो गया और इसको यहाँ से extrapolate करते हैं. ये ऐसे extrapolate करते हैं. ठीक है? और कहाँ पे रे मिला? रे हमारा जाके मिला यहाँ पे. And this is the formation of the image. बहुत interesting है ये image, अभी आपको बताऊंगा. This is the image formation. So I'm showing the image is virtual image. So I'm showing it with a dotted line. Virtuals are always shown with dotted line. ठीक है? So if I say that this is, oh, I can't write PQ. So I'm writing AB. Then my image is how? My image is A dash, B dash, right? So let us now comment. Let us now comment on each thing. Number one, let's say first we comment on position. And we are commenting everything for image. We have to comment this for every formation. Position. Position will write behind the mirror. Behind the mirror, just like a plane mirror. Behind the mirror. Number two, we talk about size. We'll say enlarged. Enlarged, or you can use the word magnified, magnified. And 3, we talk about nature. So what is the nature? First you see A became A dash. So it is erect. However, this is virtual. Can everyone tell me why it is virtual? It has not been formed by actual intersection of rays. इसका जन्म देने वाला काल्पनिक माँ बाप है. Sir, extrapolation. Got it? Erect because you see उसका arrow ऊपर था, यहाँ भी arrow ऊपर है. And behind the mirror form हुआ है. अभी भी लिखो मत, कुछ और इंटरेस्टिंग चीज है. दिस इज अ वेरी वेरी यूनिक केस. एक ही बार आएगा ऐसा केस, और ये होता है 2 केसेस में. नंबर 1, ओके, द वैनिटी मिरर. वैनिटी मिरर, यू नो व्हाट इज अ वैनिटी मिरर? जानवी को पता रहेगा. जानवी, ये फाउंडेशन या कॉम्पैक्ट में एक मिरर रहता है ना लेडीज का, ऐसे खोल के ही बैग से निकाल के ऐसे ऐसे लगा लेते हैं लिपस्टिक लगाने के लिए. एयरपोर्ट या आउटसाइड यू गेट दैट स्मॉल मिरर. That mirror is this one, this particular thing. Okay, this one mirror is seen in, this is seen in vanity mirrors, this is seen in the optimist. Optimist मतलब समझे हो, जहां पे. Then shaving mirrors, men have these shaving mirrors which are a part of their shaving kit. छोटा सा मिरर रहता है but it will give you a very enlarged picture. Optimist मतलब देखो चश्मे की दुकान में there are these mirrors kept on the desk where you wear your specs and see yourself. That is this mirror. It's a concave mirror. It's not a plane mirror. If you are understanding that it's a plane mirror, no, it is not a plane mirror. Then one more mirror is there, which we see with this. The dentist mirror. Have you seen when the doctor checks your denture, he takes a small mirror and he puts it inside your mouth and he actually looks at all your teeth, and because what is his intention? He wants to see very clearly whether you have been infected by a cavity, whether your gums are having any sore, or your gums have fallen under any sort of infection, or there is an attack on infection. So वहां पे साहब सुनो पहले, डेंटिस्ट का मिरर, आपने डेंटिस्ट का मिरर देखा है? छोटा सा हैंडल के साथ मिरर. They put it on your mouth and they just see it with that. So vanity mirror, optimist ka mirror, shaving mirrors, dentist mirror, these are all examples of concave mirror, and there the object must be near to the mirror. Dentist will never hold his mirror here and the teeth is here. He will hold it always near. आपके मुंह के सामने रखेगा, दांत के सामने. ये केस पूरा समझ में आया? It is one of the only unique case जहां आपको एक virtual image मिलने वाला है और erect मिलने वाला है. बाकी सारे इमेज इन्वर्टेड होंगे, सारे के सारे इमेज इन्वर्टेड होंगे और रियल होंगे. So next time, if a problem comes to you and they say a concave mirror produces a virtual image, immediately you think that the object must be between focus and the pole. Are you getting it? And say suppose the focal length is given say 30 centimeters, then your object distance cannot be more than 30. अगर more than 30 आ रहा है, आपका आंसर wrong है. It has to be within 30 क्योंकि pole और इसके बीच में. That we'll get to know later on. Don't break your head on this. So the first case was object is placed between pole and focus, concave mirror, we get an enlarged, erect, virtual image behind the mirror, and such sort of application is used in a dentist mirror, shaving mirror, beauty compact mirrors or vanity mirrors, as well as in a dentist mirror. ये question आता है लेकिन. A dentist uses a mirror. Could you advise what type of mirror is needed? And one more example was the spoon that I gave you. ये spoon का जो मैंने दिया. If you hold a new spoon which is there in your house, if you have a new spoon in your cutlery, take the spoon, bring it near your face, you will see an erect image of yours because you are between the pole and the focus. As you move the spoon away from your face, immediately your face becomes inverted down and it gets enlarged. Okay? Would like to draw anything or any diagrams? We can take a break and we can go to the next case after this.
So the other ray which is coming, the one you've drawn in blue, it's not deflecting anywhere.
It's through the center of curvature. That rule, a ray through the center of curvature comes back on the same path.
Okay.
Rule number 4. So your rules should be very clear. Unless your rules are clear, you will not be able to draw. Rules have to be clear. What about the reflected ray? What about the incident ray? Yes, Aryaman, are you drawing today or not? Acha, drawn. Very good. Any questions on this one? You're muted.
सर मैंने लिस्ट भी बनाया है.
अच्छा, वेरी गुड।
कि अगर ऑब्जेक्ट ये पोजीशन में इमेज कैसे बनेगा,
हाँ, वो लिस्ट में
नेचर
एक और
क्या
चीज
होगा,
क्या
साइंस
रहता है,
क्या होगा।
दैट इज वेरी गुड। इफ यू अनदर थिंग दैट यू शुड डू विद दैट लिस्ट इज, कभी कभी when once you will be 3-4 months down the line, sometimes you get confused. Okay, the list will also get, then these tricks will always help you to remember. Concave mirror, because आप प्रैक्टिकल कर लो, आज ही घर में चम्मच ले लो, अपने मुंह को देख लो. A concave mirror always gives an inverted real image, except one case, when the object is between pole and focus. ठीक है. चलिए, अब हमारा नेक्स्ट केस चले. केस नंबर 2, when object is placed at focus. Okay, our second case is when object is placed at focus. अब यहां से सब शुरू हो जाएगा, रियल बनेगा और इन्वर्टेड बनेगा. ठीक है. सो लेट अस टेक द डायग्राम. ओके, सो right, make the
So
principal.
the size will be enlarged. The position will be erect and virtual.
No, position is behind the mirror. Nature is erect and virtual.
Yes, position will be behind the mirror. Nature is erect.
ये लिखा है ना, देखो, पोजीशन बोलता है कितना दूर पे है, बिहाइंड द मिरर.
हाँ.
नेचर बोलता है इरेक्ट हो कि सीधा हो, और इरेक्ट हो कि वर्चुअल हो, रियल हो कि इन्वर्टेड हो, और साइज तो साइज जैसा आपका आएगा. ठीक है. चलिए, इसको आगे को बनाते हैं. ये हमारा कॉनकेव मिरर हो गया. अब यहाँ पे हमें नेमिंग करना पड़ेगा. सो वी नेम आवर पॉइंट्स एज, दिस इज द पोल P, दिस इज द फोकस F, एंड दिस इज द सेंटर ऑफ कर्वेचर. ये C हो गया, ये F हो गया, और ये पोल हो गया. ठीक है. एंड दिस इज योर प्रिंसिपल एक्सिस. तो सबसे पहले हमें ऑब्जेक्ट को बिठाना है. दिस टाइम ऑब्जेक्ट कहाँ पे है? ऑब्जेक्ट फोकस पे है. ठीक है. ऑब्जेक्ट को हमेशा इरेक्ट रखा जाता है. दैट्स यू मे आस्क, सर ऑब्जेक्ट इरेक्ट क्यों है? ऑब्जेक्ट इज ऑलवेज बाय डिफॉल्ट टेकन इरेक्ट. So let's draw the rays. Come on. So a ray of light which is parallel to the principal axis, right? A ray of light which is parallel to the principal axis. So let's draw that. A ray of light which is parallel to the principal axis passes through the focus after reflection. So this has passed through the focus after reflection. ये rule number 1 से हमें मिल गया. ठीक है. नेक्स्ट रूल हम क्या लगा सकते हैं? अगेन सेंटर ऑफ कर्वेचर वाला रूल लगा सकते हैं. Now, a ray which passes through the center of curvature, a ray which passes through the center of curvature comes back undeflected. So it should be something like this. Okay, it's going in this way and it's
जब
coming back.
ऑब्जेक्ट एफ में फोकस में होता है तो वो इंफिनिटी में होता है ना.
हाँ, वो बताएंगे अभी आप. करेक्ट. ठीक है. नाउ दिस इज वेरी, नाउ इफ यू सी, ये कैसा हो गया? ये पैरेलल रेस फॉर्म हो जाता है. दिस आर पैरेलल रेस. तो इसमें हमारा थोड़ा सा वी विल हैव अ कन्वेंशनल अंडरस्टैंडिंग. तो ये रेस कैसा हो जा रहा है? ये रेस पैरेलल हो जाता है, और यहां हम ये बोलते हैं कि आई डोंट गेट टू नो वेयर दे विल मीट. सो वी से दे विल मीट. इमेजेस फॉर्म्ड एट इंफिनिटी. कहीं दूर इमेज बन रहा है, बहुत दूर. और पैरेलल मतलब धीरे धीरे ये बेटा स्प्रेड कर जाता है. ये पैरेलल बन गया है, बहुत दूर चला जाता है. और जैसे ही दूर जाएगा, लेट अस नाउ कमेंट ऑन फर्स्ट ऑफ ऑल position of the image. We'll say at infinity. Okay, at infinity. Then we talk about nature. Nature कैसा रहेगा? Nature होगा रियल और होगा इन्वर्टेड. हाउ कैन आई से इट विल बी इन्वर्टेड? अच्छी तरह से देखो, ये जो सर के ऊपर के रेज है ना, ये नीचे की तरफ आ गए, तो इमेज कुछ ऐसा ही बनेगा. ऐसा इमेज बनने वाला है, दूर पे जाके बनेगा. ठीक है ना? हैव यू अंडरस्टूड? सो द इमेज विल बी फॉर्म्ड एट इंफिनिटी, रियल एंड इन्वर्टेड. एंड द मोस्ट इंटरेस्टिंग पार्ट इज, व्हाट डू यू टॉक अबाउट द साइज? वी से हाईली मैग्निफाइड. बहुत बड़ा बनेगा इमेज, हाईली मैग्निफाइड. इनफैक्ट इसका उल्टा प्रिंसिपल को ही टेलीस्कोप यूज करता है. दूर के चीज का छोटा इमेज बनाता है. And Aryaman, since you have the list, beta आप देखना, when the object will be at infinity, the image will be at focus. Just इसका उल्टा हो जाएगा.
हाँ.
और बनेगा highly diminished. यहाँ very highly magnified, वहां बनेगा highly diminished. Just इसका उल्टा. Basically आपको बेटा 3 images ही याद रखने हैं. 2 are just the opposite cases. 2 are just the opposite cases. ठीक है? समझ में आया? Highly magnified. अब देखते हैं इसका हम एप्लीकेशन कहां पे करते हैं. इसके एप्लीकेशन को समझने के लिए थोड़ी देर के लिए आपको मेरे साथ चलना पड़ेगा कोलकाता या कैलकाटा, और हमें देखना पड़ेगा क्या वहां के टैक्सीज किसके होते हैं, एम्बेसडर के होते हैं ना. किसी ने एम्बेसडर का हेडलाइट देखा है? एम्बेसडर का हेडलाइट ऐसा होता है, देखो ऐसा ऐसा गोलू गोलू हेडलाइट होता है. हैव यू सीन द हेडलाइट ऑफ एन एम्बेसडर? गोल गोल होता है ना, पुराने जमाने वाला. अब एम्बेसडर में ये हेडलाइट को ऐसे क्यों डिजाइन किया गया था, इसके पीछे एक रीजन है. जो एम्बेसडर में आपका बल्ब लगा रहता है ना, बल्ब लगा रहता है, वो बल्ब का फिलामेंट इस तरह से डिजाइन किया जाता है that the bulb's filament is at the focus. देखो मजेदार चीज क्या हो रहा है. तो क्या होगा, जो जो रेस यहां से निकलेंगी, कहां से, they will come out of the bulb, they will all be the rays which are passing from the focus, and any ray which passes from the focus becomes parallel after reflection. ये देखो, ये हेडलाइट का फंडा है, पहले पहले जब दिया था. Do you understand? So nice.
So it's just a straight beam of light.
It's a straight beam, high beam जब हम मारते हैं, and nowadays it goes and falls down. So now headlight technology has improved a lot. We do not have a particular shape. We have combination of shapes. We have got a paralleloid headlights. We have got a trapezoid headlights. तरह तरह के. But the basic funda is even when you use a torchlight, जो हम पुराना बैटरी टॉर्च लाइट भी हम यूज करते हैं, वहां भी अगर आपको स्ट्रेट बीम चाहिए तो आपके लिए सबसे पहले क्या होना पड़ेगा, यू हैव टू प्लेस योर बल्ब हैज टू बी ब्रॉट टू द फोकस ऑफ द रिफ्लेक्टर. रिफ्लेक्टर के फोकस में बल्ब जाएगा तो फिर रेस हमारा स्ट्रेट ट्रैवल करेगा, वरना रेस कैसे जाएंगे, छितर जाएंगे ऐसे करके. सो व्हेन ऑब्जेक्ट इज प्लेस्ड एट फोकस, इमेज इज फॉर्म्ड एट इंफिनिटी एंड द इमेज विल बी हाईली एनलार्ज, बहुत एनलार्ज रहेगा, इन्वर्टेड होगा, रियल होगा. ठीक है. अब तीसरा वाला जस्ट इसका उल्टा देखेंगे, याद करने की जरूरत नहीं है. तीसरा वाला, इसका एप्लीकेशन क्या हो गया, इसका एप्लीकेशन हो गया टॉर्च रिफ्लेक्टर. इन द टॉर्च रिफ्लेक्टर अरेंजमेंट व्हाट डू वी हैव, bulb is at focus. When the bulb is at focus, then automatically it happens. The third case, we'll just reverse it. When object is at infinity, when object is at infinity, let's say Uranus or some other planet, okay, when object is at infinity. अभी आप मुझे कॉमन सेंस से बोलो तो, आर्यमन मत बोलो, rest of the two, can you guess and say when object is at infinity, it has a direct relation to number 2. number 2 के साथ इसका डायरेक्ट रिलेशन है. नंबर 2 में हमने ऑब्जेक्ट को फोकस में रखा था. Tell me.
Image will be much smaller.
Okay, where should the image be formed?
Image will be formed at focus.
At focus. What should be the nature of the image? Very small, very small. And the word for that we use is called diminished. Diminished. And what about the erect or inverted?
It will be real and inverted.
Real and inverted. As I told you, in every case it is real and inverted, except the lipstick powder वाला case. ऐसे याद रखने का. लिपस्टिक पाउडर, चश्मा एंड शेविंग को छोड़ के बाकी सब केसेस में हमें रियल एंड इन्वर्टेड मिलेगा. ठीक है. तो इसको दिखाने के 2-3 बुक्स 2-3 तरीके से दिखाते हैं. आई विल ड्रॉ बोथ द टाइप्स सो यू कैन टेक अप व्हिचएवर यू फाइंड इज ओके विथ यू. ओके, सो basically you need to understand the funda in both the cases. Let's say I clone this once again, so it can be understood in 2 ways. Now object is at infinity. When your object is at infinity, you don't see the object, but as I told you, rays which come from the infinity, distant rays are always parallel. So parallel rays are coming, and both the parallel rays, what they will do, they will pass through the focus after reflection. Pole, focus, center of curvature. Pole, focus, center of curvature. Okay, so the rays should actually pass in this manner. The rays should pass through the focus. Sorry, the rays should pass through focus, and this ray also should pass through focus. Now, why this diagram is not preferred by some books? Because this diagram apparently doesn't make you feel what is the size of the object. It just shows you that the object is just like a point. It's just like a point. ठीक है? ये भी आप draw कर सकते हैं, कोई गलत नहीं है. ये point object हो जाता है, and this is what happens in the case of a telescope. Nowadays, the modern telescopes that you don't have lenses. You have one lens and one mirror. First, the telescope will have a mirror, and it will bring the image of the moon right at the focus. Moon is very big, so it will form a small image of the moon. Now you will say, but sir, the image is inverted. Are the moon is round. गोल मून का इमेज इन्वर्ट हो या सीधा फुटबॉल कभी बोलते हो क्या इन्वर्टेड है? नहीं है ना, फुटबॉल फुटबॉल है. सो मून का इमेज बनेगा फोकस में, और फिर हमारे पास एक आईपीस होता है which is a lens which we use like a magnifying glass and we enlarge that. And how the eyepiece should be? Now the eyepiece is a lens. That image should be between the pole and the focus of that lens. तभी ना उसका बड़ा इरेक्ट इमेज बनेगा. समझ में आ रहा है? See, the funda gets so easy. First of all, you will have a mirror. Mirror यूरेनस का एक छोटा सा इमेज फॉर्म करेगा. कहाँ पे? फोकस पे. फिर उस पे आप मैग्नीफाइंग ग्लास रख के यूरेनस को बड़ा करके देखते हैं. That is the funda of a astronomical telescope. Now the other drawing that we can draw for this is you show the rays little bit slanted. Say the rays are coming like this. Okay. Pardon me. Say, and the second drawing is actually more preferred. The rays are coming like this. One ray is coming in this manner. And let's say take another ray which comes and hits directly. Now look at the law that I'm going to use. This ray, the second ray is coming and hitting where? Okay, let me change the color. The second ray is coming and hitting at the pole. It's a parallel ray hitting at the pole. So what does the law tell us? The law tells the angle with which this ray has hit the pole, it reflects back at the same angle, right? It will reflect back at the same angle. So let's reflect it back at the same angle.
The angle of incidence will be equal to the
Angle of reflection when it is happening at the pole, right? And the other ray which came parallel from distant ray, it is almost touching at the focus, right? It almost touches right before the focus, so that the image is formed somewhere here. Even my drawing is very small here. I can only make an enlargement, like say, for example, if I enlarge it, it's like this, so that you get a fair bit of idea what is happening here. Now, if you see the image is formed where the two rays meet each other, okay? So the image is formed at this point. Here the image is formed. Very small. In fact, I should not draw it this way. I'll draw it this way. The image is formed here. Out here. Small image. Did you get it? So let's talk about our same things. Position. Position is at focus. Then nature, real, and inverted. Size.
So the reflected ray is passing through the focus, right?
Oh, it doesn't pass through the focus, it passes below, because it is not parallel to the principal axis. It passes through a point below the focus.
So like it, right?
Yes, देखो, ये focus है ना? If this is focus, the reflected ray is passing like this, and the other ray is just passing here, like
So
this.
this telescope में magnifier ये होता है जो it can adjust the.
Telescope never magnifies. Don't give that foolish answer in any job. If a telescope magnifies, then you should see a Uranus much bigger than your house. ऐसा होता है क्या? A telescope brings tele objects to your scope. दूर के चीजों को आपकी निगाहों में ना. टेलीस्कोप मैग्नीफाई नहीं करता है. मैग्नीफाई का मतलब क्या है? हमारा दांत छोटा था, डेंटिस्ट ने बड़ा करके देखा. आप मून जो देखते हो टेलीस्कोप में, कितना बड़ा देखते हो? इतना बड़ा मून देखते हो. मून वाकई में इतना बड़ा है क्या? मैग्नीफाई मतलब जब ऑब्जेक्ट से बड़ा कोई. माइक्रोस्कोप मैग्नीफाइज. हमारा पैरामीशियम या बैक्टीरिया इतना छोटा होता है, उसको आप इतना बड़ा करके देखते हो, वो मैग्निफिकेशन है। टेलीस्कोप कभी मैग्नीफाई नहीं करता है, टेलीस्कोप दूर के चीजों को पास लाता है। बाइनोकुलर्स कभी मैग्नीफाई नहीं करता है। मैग्नीफाई अगर करता तो फिर हमें पूरा यूरेनस कितना बड़ा है उसका, इट विल नॉट कम इन योर विजन ओनली। नेवर एवर गिव दैट आंसर, मेनी पीपल गिव दैट आंसर इन जॉब्स. So what is the how do you magnify in a telescope? Sir, telescope never magnifies. Telescope only, the magnification is done on the first image created by the concave mirror by the secondary convex lens. वो उसको मैग्नीफाई करता है। अब टेलीस्कोप में कैसा हो रहा है? टेलीस्कोप का फंडा इज समथिंग लाइक दिस बेटा। हमने यूरेनस को देखा और ये है यूरेनस का इमेज। इसको अभी एक मैग्नीफाइंग ग्लास लगा दिया जाएगा और लगा के एक बड़ा यूरेनस देखा जाएगा। दिस इज मैग्निफाइड, बट इट्स स्टिल नॉट द मैग्निफिकेशन ऑफ द यूरेनस एज ए होल। डिड यू अंडरस्टैंड? ठीक है, तो ये केस आप याद रखिएगा। इसमें क्या होता है, ऑब्जेक्ट फोकस, ऑब्जेक्ट कह रहा हूं, इमेज फोकस पे होता है, रियल इन्वर्टेड, एंड द साइज ऑफ द इमेज इज हाईली डिमिनिश्ड, वेरी वेरी स्मॉल। 3 हो गए हमारे, ठीक है। आइए, सो इफ यू सी 2 and 3 दे आर जस्ट मोसेरा और पुपेरा भाई बहन, जस्ट उल्टा है एक दूसरे का। जो 2 जानता है वो 3 जानेगा, जो 3 जानवी, देखो 2 और 3 एकदम सेम है, एक दूसरे का उल्टा। ठीक है, आगे बढ़े। द नेक्स्ट वन इज वेरी क्यूट। ऑब्जेक्ट इज एट सेंटर ऑफ कर्वेचर, ये सबसे क्यूट है। सेम साइज, inverted, real, and at center of curvature. Object is at center of curvature. ये सबसे क्यूट है। चलो इसको बनाते हैं। It's something like this. ये हमारा मिरर, और ये हमने मिरर को घिस दिया, and this is your principal axis. Mark your points. This is my pole. Okay, this is pole. This is focus. This is center of curvature. ठीक है, this is pole, this is focus, this is center of curvature. Let me make my mirror. Fine. Clear? तो इसमें हम ऑब्जेक्ट कहां पे रखेंगे? ऑब्जेक्ट रखेंगे एट सेंटर ऑफ कर्वेचर। ये हमने हमारा ऑब्जेक्ट रख दिया। सो फर्स्ट रे ऑफ लाइट कैसा रहेगा? इट विल ट्रेवल पैरेलल। कोई भी 2 रे आप ले सकते हैं, आपकी मर्जी। इट ट्रेवल्स पैरेलल, इट passes through the focus, right? And we'll have our second ray of light. How do we take our second ray of light? The second ray of light is taken passing through the focus. Okay, I'll take it this way. This is the first ray of light. The second ray of light is taken through the focus. Oh, okay. The second ray of light is taken through the focus, and any ray through the focus becomes parallel. Okay, so I have to little bit adjust this drawing, huh, children? My drawing is not correct. So ideally the image should form right at the center of curvature, but since this is not geometric, तो इसको थोड़ा सा मुझे adjust करना पड़ेगा. So pardon me for doing this गड़बड़ी. I am first making the image. Okay, image will be exactly as the same size. मैंने उसको पहले ही बना दिया. Okay, now let's see. So a ray which the other ray will be coming like this. Oh, wait 1 minute. So this ray will come like this, and this ray has to pass through the focus. Yeah, now this is my focus. This is my focus, F, and that is C, and the initial ray after reflection passes through the focus. Fine, now we are done. ठीक है, a ray through the focus. So if you do by geometry, everything will be correct. Position is at C. nature, real, and inverted. Size, same size. देखो कितना तक समझ में आया. So there is a lovely rhyme so far. अगर आप पोल पे हो तो एक स्पेशल केस, फोकस पे हो इंफिनिटी, इंफिनिटी पे हो फोकस, अगर आप सी पे हो तो सी पे ही बनोगे, इक्वल इन साइज. वेरी इजी टू रिमेम्बर. 5 और 6 एक दूसरे का फिर मिरर इमेज बनेगा. ठीक है, आइए नंबर 5 को बनाने की कोशिश करते हैं. ऑब्जेक्ट इज बिटवीन फोकस एंड सेंटर ऑफ कर्वेचर. इस बार हम ऑब्जेक्ट को कहां रखेंगे? ऑब्जेक्ट को रखेंगे बिटवीन फोकस एंड सेंटर ऑफ कर्वेचर. ठीक है, चलो. Object is between focus and center of curvature. Right. Let's mark it up. Pole, focus, center of curvature. So our object is between focus and center of curvature. So let's place the object. Object is somewhere here, between focus and center of curvature. Like this. Right. So let's put our rays, a ray of light which is parallel to the principal axis passes through the focus after reflection. तो ये तो clear ही रहता है. So let's make it a ray of light. And the other ray, how we'll do? The other ray we will use straight R, the ray which is from center of curvature to the object in such a way that this ray comes and intersects here. Okay, the ray went in this direction and the ray came back in this direction. So where have they met? Sir, they have met here. Is it an actual meeting? Yes,
No.
sir, it's an actual meeting. And how should be the image look like? So we will get a magnified inverted real image. ठीक है, तो यहां लिखते हैं अभी. And can we name it? Or we should also name our images. I have not named in any cases. Still, and let's name them. Okay, this was AB and the image is A dash B dash inverted. This was AB, the images come B dash A dash. So we say position. Position is beyond C. Beyond C. Size enlarged, or you can say magnified, and nature will say real and inverted. ठीक है, real and inverted. Did you understand? Easy है. The next one will be just opposite. So where will our object be? Object will be beyond C. Image कहाँ form होगा? Between C and F. कैसा होगा? Real. Smaller in size. Inverted. Just इसका opposite करना है. करें? Let's do just the opposite of this. Number 6. Object is beyond C. So let us make the mirror. Okay. Let's mark our points. Pole, focus, center of curvature. Where is our object? Object is beyond C. Object is beyond C.
So,
ठीक है?
sir, the fifth one,
हाँ,
the fifth one, the red ray, it's passing through the focus.
हाँ, it is a red ray is parallel to the principal axis, so it will pass through the focus. Rule number 1. क्या confusion है? बोलो बेटा. बोलो बोलो.
वो ये जो ब्लू वाला जो रे है वो
हाँ, that is passing through the center of curvature, undeflected आ जाता है फिर वापस.
हाँ तो ये इमेज बीच में कैसे फॉर्म होगा? पैरेलल होना चाहिए.
कैसे पैरेलल होगा? क्यों पैरेलल होगा? Center of curvature between 2 points there can be only one and only one unique line. The line has to pass through C and the tip of the green arrow. There can be only one line. दो लाइन हो ही नहीं सकते. 2 पॉइंट के बीच में कितने लाइन हो सकते हैं? एक ही पॉइंट लाइन हो सकता है ना. क्या कंफ्यूजन है बेटा? बोल. क्या हो गया? बोलो ना, मुझे बोलो, मैं क्लियर करता हूं ना.
ये green tip can be anywhere.
Why green tip can be? Green tip, green is the size of the object. Why are you blacking out, Sahib? Green is the size of the object. An object has a fixed size, right? मैंने इस साइज को इतना बनाया है. आप इससे बड़ा लोगे तो फिर वहां से रह जाएगा, मिरर कट हो जाएगा आपका.
अच्छा, हाँ, okay.
If you stand in front of a, no, listen to me. Have you seen lot of dupattas and other dresses which have got mirrors in them? हाँ या ना बोलना. देखा है ना? उस दुपट्टे में तू तेरे को अपने आप को पूरा देखेगा क्या? मिरर में नहीं ना. Why? Because your object is much bigger than the mirror. So in order to have the complete image, let the whole object be focused to the mirror ना. That's why the object size is taken that, ताकि मिरर के अंदर आए. अब क्लियर हुआ? अब लास्ट वाला केस इसका ऑपोजिट है. तो कैसे होगा? रे ऑफ लाइट which is parallel to principal axis will pass through focus. करा दो. ठीक है? And another ray of light which passes through the center of curvature remains undeflected. ये यहां से गया और यहीं पे वापस आया. और लाल वाला कैसा था? यहां से गया, यहां पे वापस आया, यहां पे वापस आया. अब इमेज कहां पे फॉर्म होगा? इमेज बिटवीन सी एंड एफ फॉर्म होगा. यहाँ पे उल्टा इमेज फॉर्म होगा. सो लेट्स राइट इट. अगर ये ए था देन दिस इज ए डैश, और अगर ये बी था तो ये बी डैश होगा. क्लियर? और ये जस्ट उसका ऑपोजिट है, ऊपर वाले का ऑपोजिट है. देखो ना, वी कैन राइट इट. पोजीशन इज जो उसका इमेज ऑब्जेक्ट था वही लिखो. बिटवीन एफ एंड सी. नेचर, रियल and inverted, and size smaller than object. Just reverse है उसका. देखो, हमने 6 केसेस देखे. सबसे पहले पोल याद करते हैं. पोल एंड फोकस कौन सा है? इट इज द शेविंग मिरर, लिपस्टिक मिरर, स्पेक्स मिरर, whatever you want to call it. वर्चुअल होगा, enlarged होगा. सेकेंड वाज इंफिनिटी, फोकस पे. फोकस इंफिनिटी पे. सी पे. बिटवीन सी एंड एफ, बियॉन्ड सी. बिटवीन बियॉन्ड सी, बिटवीन सी एंड एफ. खत्म. दैट्स द 6. ठीक है? अब इसके थोड़ा सा इस चीज को थोड़ा सा और स्टडी कर लेंगे. ये वाला केस इस वाले केस को थोड़ा सा और स्टडी कर लेंगे, ठीक है? We'll just study this a little bit more for some interesting things. It's just a separate study. Okay, let's see this. This is only for a study perspective, nothing more than that. मैं यहाँ पे एक लाइन ड्रॉ कर लेता हूँ. Let me remove this.
सर 1 मिनट ऊपर जा सकते हैं?
जरूर जरूर, 1 मिनट दीजिए मुझे. Are we done? Let's see this one. When object is placed at infinity. इसके हम लोग 2 applications देखते हैं, 2 applications. One of the application I have already discussed with you, and that is the dish antenna. अभी आ गया dish antenna, समझ में आया? Object is at infinity. So how does your dish antenna function? Your dish antenna is functioning in this manner. So this is my dish antenna, right? And let me take the principal axis of the dish antenna. This is the principal axis of the dish antenna. Sorry. This is the principal axis of the dish antenna. And all the rays which are coming to the dish antenna are parallel rays from the satellite. These are the rays. And these rays pass through what? These rays pass through the focus. Agreed? This is a classic example. And this focus will be the place, as I told you, this will be the place where the LNB of the dish antenna will be fitted. Here. Got it? And the second one is like, you know, have you seen ENT doctors? Have you seen how ENT doctors, sometimes if you have an infection in your ear, the ENT doctor wears a headband. I don't know whether you have anytime seen that. It has got a DVD like thing in front of his face. ऐसा देखा है? अरे डॉक्टर्स का ऐसा एक हेडबैंड रहता है, ऐसा रहेगा और यहाँ पे ऐसा एक डीवीडी जैसा एक डिस्क रहता है. And the doctor wears the headband on his face, on his head.
सर हाँ देखा है.
Okay, मेरे साथ हो चुका है इसलिए मुझे पता है. यहाँ पे ये ऐसा टाइप का एक मिरर रहेगा. The doctor wears it. ये डॉक्टर क्या करेगा? अपने हेड पे पहन लेता है. So let's say this is the doctor. Okay, this is the doctor. ये अपने इसमें पहन लेता है. And then here will be the patient's ear. ये patient का infected ear है. And the doctor will illuminate a bulb here. एक stand रहेगा. Stand से rays आएंगे. कैसे rays? यहाँ से parallel rays आते हैं. यहाँ पे bulb रहता है. ये डॉक्टर के यहाँ पे rays आएंगे ऐसे, ऐसे. And all these rays will go and meet at the focus. कान को देख लेता है डॉक्टर आपके. डेंटिस्ट का मिरर यूज करता है पोल वाला, ये यूज करता है डिस्टेंट वाला. ये याद रखना. ये दिस इज ENT's मिरर. डेंटिस्ट मिरर इज ईयर नोज थ्रोट, जो डॉक्टर देखता है ये उसका होता है. क्लियर? डॉक्टर का थोड़ा छिन थोड़ा ज्यादा ही आड़ा टेढ़ा हो गया है. क्लियर? So these are the 6 cases through which we see mirror from image formation. And if you go to Lakshmi Singh, after that what they have done, they have made a matrix and summarized the whole thing So sometimes they may ask you, what is this mirror? You will say this is a concave mirror. An application based question may come to you. They may say, find focal length of a concave mirror. How will you find out the focal length of a concave mirror? Very simple. You take a mirror. This is your concave mirror, right? And you take a distant light source, sir, this and benchmark this place. Benchmark this place wherever it is. Sorry. Let's say I benchmark this place. I benchmark this. यहाँ पे mark कर दो, right? And this is your, say, a sort of scale. And then you keep on moving your source light. Suppose there is a source light. This is your source light. There's a source light. The rays from the light are coming in what manner? So they are all coming parallel. They are coming parallel. So they should all go and meet at the focus. So they have all met at the focus. बस ये आप घर पे भी कर सकते हो. And then just measure this part. This is your focal length. Did you get the idea? Take a concave mirror and fix the concave mirror. Move your light source. आगे पीछे light source को move करो. जहां dot form हो जाता है वही आपका focus है. Exactly where you get a dot, that is your focus. Okay. So we had a power failure.
सर
बोलो.
आज थोड़ा अर्ली डिस्कस कर दो क्या?
हाँ, मैं भी आज भी, मेरा भी तबीयत ठीक नहीं, आज यही छोड़ दूंगा. ये फोकस है and this is focal length. चलो आज यहीं पे डिस्कस कर देते हैं. Even I am not feeling well. ठीक है. So this much you all revise.